So this is number 2. This is which equation has x equals minus 6, right? Which equation has x equals negative 6 as the solution? So we have all these ones. We have all these multiple choices here. So we're given 4 equations. We have to know which equation has x equals negative 6. So let's solve all these equations here. Let's do A first. So A is log base x 36 equals 2, right? So in order for us to do this problem here, what we're going to have to do is we're going to have to do we have to move log to the other side, right? If we move log to the other side, what we're doing is we're taking the inverse of logarithm, which is exponent, right? So in order for us to do that, we're gonna have to move log x to this side here, and when we move it to the other side, we're going to get 36 here. So we're just left with 36. So let me draw this out. So if I move log x to the side, I'm doing the inverse option, right? So inverse of log is exponential, right? So knowing that, what I can do is I'm left with 36 on this side. I have equals 2 to the power of x, right? To the power of x here, to the power of x, right? So again, and once I have this, what I can do is I can take the log of both sides to solve for this problem here, right? So I can do log 36 equals, this is log to the power of 2 to the power of x. I'm taking log of both sides. What I can do with my logarithmic rules is I can bring this x down to here. So I would get log 36 equals x log of 2. And then what I can do is I can then move log 2 to the other side and divide both sides by log 2. So log x equals log 36 divided by log 2. And this here I can plug into my calculator. So x would equal, let me see here, log 36 divided by log 2 would get me like 5.17 or something like that. So 5.1699 or something. So if I take, again, I can plug it back into my my x here, and I get very, very close to 2. So this here is my answer for a, which is not x or equals 6, right? So this here is a here is not the correct answer. Okay, let's do B now. Log base. Let me just check this answer. 5.7 equals of 36. Yeah, it's about 2. To the power of, yeah, about 5.17 here. Okay, so let's do B here. So B here states that log of 3 is 2x minus 9 equals 3, right? So I have, again, what I'm going to do is I'm going to move log 3 to the other side. So move log 3 to the other side, I get 2x minus 9 just by itself. And I already have the base of 3, right? So it's going to be 3 to the power of 3 here. So I'm going to have 2x minus 9 equals 3 to the power of 3. 20 is 3 cubed, right? Which is 27. And then I simply just solve this as an algebraic expression, right? So I'm going to move minus 9 to the other side. So I'm going to add positive 9 to both sides. So 27 plus 9, here is 36. X would divide both sides by 2. X here equals 18. So B is also does not have it as a solution. So let me look at C now. C here is log 3 of 216 equals x, right? So I can do, so this one I don't have to actually move it. But what I can do is I can actually, if I want to plug in my calculator, I can do log, I can do the change of base, right? So we can say that log of 216 divided by log of 3 equals something, right? So I'm doing a change of base in this case. So I can say that log 3 of 216 would equals 4.89. Give me a second. Let me just check this. 4.89. Yeah. So I can do a change of base. X equals log of 216. So instead of base 3, I'm changing it to a base 10. Log of 3. And then you can plug this in your calculator. And you get log 3, 216. You get 4.89. Which again is not my answer here. So D here, let's see if I have any luck in getting x equals -6. It's log of 3, base 3 times -2x minus 3 equals 2. So what I can do is, again, I'm going to move log 3 to the other side. If I do that, it's going to be -x minus 3 equals 2 to the power of 3, right? To the power of 3. So -2x minus 3 equals, take 2 to the power of 3 here is 8. And then I'm going to have minus 3 moved to the other side would be plus 3. So I have -2x plus 3 is 11. X would equal -11 over 2, which means that's not the solution here. So for some reason, I'm not getting a solution for x equals -6. So let me just check the solution to make sure we have something here. So what they did was they actually put x into the solution. So that actually probably makes more sense for us to do that. So for A, they did, they plugged in -6, and this equals 2, right? So in this case, what they did was they plugged in x equals -6, but in case you can't, logarithms are only defined for positive real numbers, right? So the log of -6, log base -6 of 36, and again, you're going to get a math error, right? Because you can't take a log of a negative number. So A is definitely incorrect here. That's fine. B here, we had B here, this says if you plugged in -6 for this x value here, you would get log of 3 equals 21, right? So -12 minus 9 is 21. And this here is not true, right? Log of 3, log base 3 of -21. Again, you're going to do a math error because -21 is not, you cannot take a log of a negative number. And then I have the third option here is log base 3 of 2216. If you plug that in, here is 4.89, right? Like we did here. So this term is wrong here. And then lastly, I have this here is -2x minus 3 log base 3, right? So they plugged in -6 here, and they got a solution. Okay, so the reason why they got a solution was they actually plugged in -6 here. So let me just do that work for you instead of, because what I did was I solved for x instead of actually verifying x as a solution. So I approached it the other way, and sometimes that might not give you a right answer. So in this case, it doesn't. So log 3, I'm gonna sub in -6 minus 3 here equals 2, right? So log base 3, -2 times -6 here is -12 minus 3. Sorry, it'd be positive 12 minus 3. Right? -2 times -6 is positive 12 minus 3 equals 2. Log base 3 at 12 minus 3 here is 9 equals 2. And then obviously 2 equals 2. Right? So this here is my correct answer, because log base 3 of 9 is 2, right? So this here is my correct answer. Therefore, D is here as the solution. So that's good. Or you can say that we can say what they did here was they just moved log 3 to the other side, and it still works as well. So let's see. Oh, I think I made logarithms the base actually. So that's actually my fault. Okay, so let me I'm going to redo my math here. So I think my math was wrong. So what I did was I actually placed it in terms of the exponent and not the base, and that's my fault here. So let me solve for x again. Sorry folks. So if I move log 3 to the other side here, I get -2x minus 3 equals, this is 3 squared, not 2 cubed. Remember, the logarithm here, the base here, is also the base at the bottom. So that's actually my fault. I put it as exponent here. This is -6x minus 3 equals, this here is 9. And then I have -x minus 3, which means it's positive 3 on the other side, right? So 9 plus 3 here is 12, and then x would equal negative 6, right? I'm dividing both sides by negative 2, I would get negative 6. So D here is my solution. So that's my fault, sorry. I put it as the exponent and not the base. So totally my fault. So this here is great solution and analysis.